طيب بسم الله الرحمن الرحيم. So last time we started to talk about the ESP and as part of the IP6 standards, and we talked about the anti-replay attack mechanism. We talked about the window technique when we decide that the packet is going to be discarded, when we decide to slide the window, and so on. So to continue talking about the standards, we have, as we said before, we talk about two options. Either we use ESP for both encryption and authentication, whether by in the tunnel mode or in the transport mode. That's possible. The other option is that we use ESP for encryption, and we use AH, which is another part of the standard. We use AH for authentication. So we need to discuss how can we how can we decide whether to encrypt first and then we authenticate, which means that we calculate the MAC based on the encrypted data. Or we can calculate the MAC based on the plain text first, and then we encrypt everything. Okay, so we can do either way. So is there any benefit or any advantage of doing it one way over the other or not? The standard itself does not dictate. So you can do either way. You can do them in any order. The standard does not dictate. In fact, the standard recommends certain order, and they claim to have some benefit, but in all cases they don't restrict. So هنشوف دلوقتي يعني. I don't agree with that, and I think it's perfectly possible to do it either way. There's no preference for one over the other. Basically, they claim that if you do the authentication first for the plain text and then you cipher everything, this is better. Okay, but I don't see it this way. I will talk about why. So for the case of, or the option of using ESP both for encryption and authentication, so this is the option that we need to talk about now. So in this approach, usually what happens is that the sequence is first the user applies ESP law for encryption يعني, to the data to be protected, and then appends the authentication. First we encrypt, as we said, the payload, and if we talk about the tunnel mode, then we encrypt also the inner or the original IP header, صح? Okay, we encrypt, and then after we encrypt, we calculate the MAC based on the encrypted data. You could do that, ماشي? So if we talk about the transport mode, then we encrypt the payload only. The payload includes the data and the TCP header only from the upper layer. Okay, we don't encrypt the original IP header, صح? And then after we encrypt, we calculate the MAC based on the encrypted data. ماشي? So that's for this option. For the tunnel mode, we encrypt both the payload and the original IP header. Okay, and after we encrypt the payload and the IP header, then we calculate the MAC based on the encrypted data for both, again, the MAC and so for both the payload and the original IP header. ماشي? So for both cases, authentication applies to the cipher text, not to the plain text. For both cases, فإحنا we encrypt first, and then after encryption, we have a cipher text. Either it includes the payload or the payload and the IP header, صح? And then after this, we calculate the MAC. You
said before that we get the plain text first, and then we...
Yes, cipher text, yes. We do the authentication for the cipher text.
In both cases?
Yes, for both cases, whether we talk about the transport mode or the tunnel mode. يعني basically, this is how it looks like. So you have, of course, you have the upper layer data. So this is the payload. Okay. So the payload is coming as plain text. Okay. So let's talk about the transport mode. For transport mode, then you have to add the ESP header, and the ESP header in that case will be used both. This is the option, both for encryption and authentication. So what we do is that first we have to encrypt the payload. After we encrypt the payload, then we calculate the MAC, and the MAC, both the MAC and the encrypted header, okay, or the ESP header اللي هو for encryption. ESP header اللي هو for encryption اللي هو contains what? Contains mainly اللي هو ال SPI اللي هو ال security parameter index اللي هو it refers to the security association where I can get all the settings and all the parameters to be able to decrypt, okay? And then we have the same for the MAC. Also, we have to also include all the parameters and the techniques that we have used for MAC in order to verify the MAC. So we need to decrypt and we need to verify the MAC, right? The only issue here is that whether we calculate the MAC on the ciphertext or we calculate the MAC on the plain text and then we encrypt everything. يعني the order بس. ماشي? So here in this option, mainly the standard talks about the fact that we encrypt first the payload, okay, and then after we encrypt, we calculate the MAC, okay, based on the encrypted text. The encrypted text اللي هو اللي احنا بنسميه cipher text. واضح يا ناصر ولا متلخبط ليه؟
السؤال يعني ممكن يكون فاهم شوي بس احنا كنا encrypt هذا only in channel mode.
احنا مش we're not encrypting the IP header. احنا ال IP header لسه هيجي هنا. في الترانسبورت مود لسه في هنا اللي هو الاوريجينال IP header. اوكي هيجي بعد الاي اس بي. اوكي لانه ترانسبورت في الترانسبورت مود هو ايه؟ الاي اس بي بيجي قبل الاوريجينال هيدر، الاوريجينال اي بي هيدر. لو في التانل مود ده هيبقى هنا اوكي وهنكريبت كل حاجه including the original IP. And because we encrypted the original IP we have to put another outer IP. ده في التانل مود. واضح كده الموضوع؟ احنا هنا this is not what we're talking about. What we're talking about here is only the order. Should we authenticate the ciphertext or we should authenticate the plain text and then we perform the encryption after this? That's the only issue we're talking about now. ففي الحالة ديت احنا we have two options. The first option here ان احنا we use ESP both for encryption and authentication. في الحالة دي the standard talks about the order of ان انت you do the authentication for the ciphertext. Okay? هل في benefit للموضوع ده؟ No. You can do them in any order. And this is the general rule, by the way. You can do authentication to the ciphertext or to the plain text. Doesn't matter. Doesn't matter. There is no specific benefit to this. ماشي؟ In fact, we will talk about a claimed benefit, but actually for me, this is not a benefit, and I will talk about why. Another way, we talk about another way to apply the authentication after the encryption is to use two bundled transport security sessions. That's for the option, we call this a transport adjacency. For transport adjacency, we have ESP for encryption and AH for authentication, right? So in that case, you have to use two security associations, one for ESP and one for AH. Okay? ماشي كده؟ We call this ايه بقى؟ bundled security association. Bundled معناه ان انت عندك two security associations but actually they are bundled together because both of them are required to have the tunnel or to have the encryption and authentication. But in fact, one security association is for encryption and one security association for authentication. ماشي كده؟ So in this case, ASP is used without its authentication option. This is the either IPsec version 1. This is the only option that's there, or IPsec version 2. But this option is kept for a backward compatibility. ماشي كده؟ So in that case, if we're talking about so encryption is applied to the IP payload for the transport mode, AH is then applied to the transport mode. ماشي? That's if we talk about the transport mode. So for transport mode, if we have ESP and AH, we have two bundled security associations, okay? And in that case, we have ESP for encryption and AH for encryption. One thing here is that they are claiming to have some advantage here, is that now advantage of this approach is that the authentication covers more fields. Why? Because if you apply first the encryption, so we have, again, we're talking here about the transport mode. So you have the payload, okay? And then after the payload, you have ESP, ماشي? Okay? So you have the ESP, which means that, again, this is a encrypted, okay? And then you add the AH. When you add the AH, you can calculate the MAC based on both the payload and some fields from the ESP, because ESP is applied first. So for authentication, you calculate the MAC based on the payload and some fields from ESP. فبيقول لك يعني this is an advantage. لأن يعني this is like, it's like you are authenticating or you are verifying not only the payload but some fields from the ESP. فhe's talking about this as an advantage. يعني. If you have ESP for both, okay, then in that case خلاص you do the authentication or the MAC based on the payload only. خلاص ما انت ما تقدرش تعمل the ESP is now used for both. ماشي? But here, because the ESP is separate from AH, so when you add ESP for AH, you can add some feature or some fields from ESP when you calculate the MAC. And this is يعني, a slight advantage. يعني. But again, it's not really a big advantage. Why? Because there is a disadvantage corresponding to this, which is you need to have two security associations, because you have ESP separate from AH. And we have bundled security association. So we cannot have one security, we have to have two. And having two security associations for the same logical connection, okay, is an overhead. صح؟ لو انت, if we're talking about the first option اللي هو having ESP both for encryption and authentication, you have one single security association, right, for the tunnel. In that case, it's the overhead is less. ماشي? So the advantage is that you can authenticate more fields from ESP, but the disadvantage is that you have overhead by having two security associations. ماشي كده? So that's that option. So the standard tries to be more complex الحقيقة by saying, okay, so why stop there? So we can have any combination. If we're talking about ESP separate from AH, we can in fact have ESP using transport mode, but AH using tunnel mode. Theoretically speaking, nothing would stop us from doing this. Okay? Which means بقى ان انت ممكن تعمل you can have payload theoretically يعني, although this is not very common, but I will tell you some scenarios where this might be used. So you can have ESP, okay, and after ESP you can add the original IP header, okay, but then you can add the AH in the tunnel mode, which means that AH will include the authentication for everything, okay, or the other way around. Okay, so you can have the ESP here, and in that case you have to have outer IP. And the standard does not dictate a specific sequence. ماشي? The standard says everything is possible. ماشي? So you can do the encapsulation in any order you want. So you can have the use of authentication prior to encryption. That also might indicate that you might have to add the AH before ASP, which means that you need to calculate the MAC ماشي before the encryption. ماشي? So the sequence doesn't matter. So the standard بقى says, which I disagree with, honestly. The standard says the use of authentication prior to encryption might be preferable. Why? Why? لأنه بيقول لك هنا إيه? It's impossible for anyone to intercept the message and alter the authentication. Why? Because when you encrypt, you can encrypt everything including the MAC itself. ماشي؟ فبالتالي you don't have access to the MAC until you decrypt. Okay? They say that this is a benefit. يعني. ماشي? So that's one thing. The other thing, which I totally disagree with, it may be desirable to store, because again, you have the plain text, huh? And you calculate the MAC based on the plain text, okay? Before you encrypt everything, you say, okay, let me store this pair that this is a plain text and this is the MAC that corresponds to it. Let me store them in the cache. Why? Okay? Because if you have the same plain text repeatedly, ماشي, you don't have to calculate the MAC every time. So you say you save time. يعني. Why would you do this? Why would you do this? I don't see really a real benefit for doing this. And you store in the cache the payload and the MAC that corresponds to it. You don't have to store that pair in the cache because this depends on the application, and the application feeds different data every time. Okay? But in case that you recognize that you are sending the same data over and over and over again, then you can just go to the cache and get the same data with the MAC and send it right away without calculating the MAC over and over again. Yeah. So you try to reduce the complexity of calculating the MAC. That's what they are trying to say here. You are trying to save complexity by saying, okay, so instead of calculating the MAC every time, because this is a plain text and I can recognize that this plain text is sent over and over again, so I have already the MAC for this stored in the cache, so instead of calculating the MAC, I can just get it in the cache and just encrypt it again and send it, encrypt it again and send it, encrypt it again and send it.
So it's plain text, not even encrypted in the cache?
Right. But local, you're not sending it plain text. It's stored locally and it's plain text. Once you send it, you have to encrypt it, of course. But the fact that it's local, so assuming the application is trying to send the same data over and over and over again. I don't see why would you do this? But let's assume that this is happening. So instead of saying, okay, so it's encrypted and I have to calculate the MAC, because every time you encrypt it, you don't know, so you have to calculate the MAC again and again. So if it's a plain text, you can say, okay, so I have the MAC already calculated, I don't have to calculate it again and again.
So maybe for, let's say, sending the packets, always the same requests over and over again.
That's going to be different, different destination, different...
I don't really, because I mean, again, the network layer has to be application agnostic. The network layer has to be application agnostic. So every time you get a data from the application, you have to treat it as a new data, even if it's the same. Otherwise, you will have to learn how the application really works. And remember, you have higher layer headers. So even if you have the same data coming from the application, at least you will have a different TCP header because you have to have the sequence. صح? You have to have the sequence number. So, and in fact, if at the network layer, if you try to analyze the TCP header and say, oh, okay, so it's a different sequence number, but the payload is the same, then you are application dependent. And the network layer should be application agnostic. It should not really be dependent on the application. Anyway, so they are claiming this is a benefit, the specific sequence, to try to authenticate the plain text to have a certain advantage, which I don't see it as real advantage anyway. So one approach is to use a bundle consisting of an inner AH transport, okay, as we said. So this will be based on the payload, but then the ESP would be tunneled. ماشي? The ESP itself would be tunneled. ماشي? So that's another. So this ultimate flexibility really makes حتى the standard يعني complicated. Makes the standard really complex. Type. The result is that the entire authenticated inner packet is encrypted. يعني كل ده, including بقى the original IP address. Even though the AH is transport. AH is done only for the payload, right? But the encryption is done to the entire thing. ماشي? So this flexibility really makes it a little bit difficult. ماشي? So these are some scenarios which in fact it makes sense, but you will see that in order to do both transport and tunnel mode, okay, it has certain scenarios which يعني deems using both relevant and really يعني practical, but in that case you have to have two levels of tunnels. You have to have two separate tunnels basically. Okay, so the more typical scenario is that you have two tunnels يعني inside each other. Okay, but the option in أنت تستخدم AH for transport and ESP for tunnel, okay, that's يعني not likely, not practical. But the more practical scenario is what you are talking about here. So here you have this is a transport mode clearly, okay. So I can give you a graph like this, and then I tell you, do you think this is transport mode or tunnel mode? Clearly this is transport mode. Why? Because it's host to host على طول. I don't have to tell you that. صح? Host to host معناها إيه? The original IP header should be preserved, because you have to preserve the local IP address and the ultimate IP address, because this is the beginning and end of the tunnel. Okay? So you cannot by any means encrypt the original header. مش ممكن, ما ينفعش. ماشي? طيب, this is of course case 2 is for the tunnel mode, and we can use bundled security association for the transport mode, which means that we are using ESP, okay, for encryption and AH for authentication. We have two security associations. That's why you have two كده inside each other. That makes sense, صح? ماشي? And this is transport mode. ماشي? So this is bundled security association. Okay, you have ESP and AH. Just by this graph, but just by looking at the graph, you recognize all this information. That this is bundled security association. You have ESP for encryption, AH for authentication, right? And this is a transport mode clearly, because this is host to host. ماشي? Here, for this scenario, it's clearly ESP for both encryption and authentication. Why? Because it's actually one tunnel. ماشي? And this is tunneled mode. It's not from network to network. واضح. From network to network, which means that the original IP address between any host and any destination is in fact encrypted. I don't care about the original header inside that tunnel. So inside that tunnel, I don't care about where it's coming from and where it's going to. But what I need to know is what is this IP address and what is this IP address, which is stored in the outer IP header. برافو عليك. بس ماشي كده. And this is one ESP header for both encryption and authentication. واضح. تمام. Here بقى this is بقى complicated scenario شوية. فأنت عندك one bundled security association, which means ESP and AH, ماشي, for host to host, but this is in fact inside another tunnel, ماشي, security association, which uses ESP for both encryption and association.
So it's like a transport mode inside the tunnel.
Yes, transport mode inside the tunnel mode. The standard allows this. And in fact, in real life, that could be used. يعني it's okay. يعني مثلا in your house, or بلاش in your house, يعني you can have مثلا two مثلا Microsoft offices, they have intranet, okay? Which means that already any traffic coming from this local network, it will have to go through the tunnel. You don't have an option. However, you choose to have another transport, okay? Another transport IPsec. Why? In order to also secure the traffic inside that network. Okay? But in all cases, all the traffic going from that network will have no choice to go through the tunnel anyway. And that's possible. Of course, طبعا هنا we have the security policy database. And according back to the rules, we can specify the rules here to say, if you have an incoming traffic that's IPsec, maybe I can bypass it, or I can send it inside. It's up to you. But the standard allows all of these scenarios to happen. ما فيش أي مشكلة خالص. ماشي؟ Flexibility. ماشي؟ طيب, so هنا احنا we're talking about a transport mode. هنا we're talking about two tunneled mode inside each other. Two tunneled mode, because between host and a network, in fact, لا, this is the ثانية واحدة. This is the transport mode. لا, this is transport mode, صح? Because this is host to host, صح? So you can have the transport mode itself, again, bundled security association. So you have here two security associations, which means that one or two security associations, which means that it's bundled. Again, it's ESP and AH. And then you have the tunnel mode between the host and the network. Yes. So the difference here is that the tunnel mode is not between offices or between two networks. Here, it's between a host and a network. ماشي? And that's possible. يعني assuming مثلا أنت مثلا outside QU, ماشي? And you want to first have a VPN connection, ماشي? First, to only connect with the QU network. Having this will allow you to have an IP address inside QU. If you have an IP address inside QU, then you can at least know all the servers inside QU. ماشي? But then, in order to connect to a particular host inside QU, you may choose to use another tunnel or another transport mode IPsec, okay, to access a particular server inside QU. ماشي? So in that case, you are using a tunnel mode to connect to QU in order to be able to see what's inside. ماشي? By doing this, you get an internal IP address inside QU, which will allow you to see what's inside. But then, if you want to connect to a particular host, you also want to use another VPN connection. Why? In order to make the traffic here also secure. Because otherwise, what will happen inside this tunnel, the traffic will be secure, encrypted, and authenticated, and everything. Once you reach here, the traffic will be decrypted, صح? So if you want to also secure that part, then you can have another VPN connection. But the first one is important to be able to see aslan what's inside. So that's a common scenario where you have to use that particular application. ماشي? So in all cases, the standard is ultimately flexible. It gives you ultimate flexibility to use bundled security associations in any form. Okay? And you can have two nested tunnels, one transport and one tunnel mode. Okay? Or the other way around. ماشي كده? Particularly this scenario here.
Yeah, but in case 4, there's a tunnel between the host and the router and the security gateway.
ما فيش, we have only one tunnel, which means that the traffic inside this network and the traffic inside this network is exposed. It's not secure.
Case 4.
لا case 4 بقى خلاص, case 3 أو case 4, this is بقى dynamic. We cannot use the manual. We cannot use the manual in this case. طيب, so we'll start بقى الجزئية بتاعة we'll start a little bit الجزئية بتاعت الانترنت key exchange. احنا قلنا دلوقتي if the traffic is coming in, okay, and the traffic has a rule in the security policy database, then we apply this rule using the selectors. Remember, we apply the rule using the selectors. ماشي. If we apply this rule, then the security policy database should give us the SPI of the security association. So what if that security association was not established yet? So for the first time, the traffic is coming in, and there is no tunnel constructed, or there is no security association constructed. Then we have to go through our key, internet key exchange. So now we need to talk about, this is the last topic of this chapter, is to talk about IKE. So IKE is used for key management, okay, and key generation, and in that case, we establish the security association for the first time. طيب. So a typical requirement is at least to have, in order to have communication back and forth, حتى host to host أو كده, you need to have a communication back and forth, صح؟ بس احنا قلنا in IP itself is connectionless, okay? So you need to have, so again, if you have مثلا host to host through the network, okay, then you need to have IP traffic going this way, but you definitely need IP traffic to go on the other way, right? So as we said before, the security association itself is one way. But definitely, for each direction, you definitely need at least two keys, one for encryption and one for authentication. ماشي? At least two keys. Whether one of them is public, one of them is symmetric key, whatever, but we need to have two. So you need to have two in one direction and two for the other direction, okay? But the security association will contain two of them, okay, in one direction. The security association itself is one-way logical security connection, okay? But definitely, for communication, we need both ways, in which case we need 4 different keys, at least. But in fact, we do need to have also other things like IVs, initial vectors, or we'll talk about other definitions like cookies, nonces, things like that. We do need to have these, right? But at least we have to have these 2 basic keys in each direction, in which case we have 4 in total.
So SA is one way.
One way, طبعا.
Due to IP is
Yes, due to the fact that IP is connectionless. Yes, exactly. We said that before, okay? If you go back to the definition, the basic definition of security association, it's a one-way logical security connection, right? And this is because of the fact that IP is connectionless. ماشي؟ طيب. So these 4 keys, by the way, can be done using 2 approaches. The manual approach, in other words, these security associations, there is a chance we can construct this security association manually. We have to create it manually. Similar, فاكرين static routing و dynamic routing? ماشي. It's possible. مثلا if we have at QU مثلا, or let's not talk about QU. We have 2 offices, and we need to contain these 2 offices only in an intranet. You have 2 branches of an office. So you can implement one security association using ESP for both encryption and authentication, and it's one tunnel between the 2 offices, and that's it. Okay. So in that case, you can construct the security association manually, because the tunnels that you want to create is not dynamic; it's fixed. And it's permanent. ماشي? So it's exactly similar to static routing and dynamic routing. So I can construct this security association manually. It's possible. ماشي? So the system administrator in that case manually configures each one.
Wait, that's what you said, the tunnels are permanent and...
Yes.
Right, so within an intranet, are there permanent tunnels between the routers?
Yes, absolutely. طبعا. Yeah, which means that any traffic coming from this office will have no choice but going through the tunnel. You don't have an option.
Like
خلاص.
go to the router and then the router through
The router will have to feed it through the tunnel. يعني
right.
على طول. Okay.
The key changes.
The key changes dynamically. Yes, the key changes dynamically. We can see that. صح. That's a good point. صحيح. The security association, just the fact that it's permanent doesn't mean the security association should not change. Because the keys should be dynamic over time. Otherwise, if you keep it permanent, this will simplify the crypto analysis. Okay, that's why actually the manual approach is not used. Manual approach is not used. So the automated approach is that you need to have that again, some way of handshaking in order to establish security association based on certain logic. The logic, as we said before, لو في security policy database tells you that you need to apply this rule, but the selectors refer to SPI that does not exist in the security association database. So you need to establish a new one. Okay, so you have to trigger the request to IKE to establish a new security association dynamically and on demand. ماشي? So we need to find what are and it's possible it's different here بقى from فاكرين اللي هو extensible authentication protocol. لا, here is totally different. هنا بقى is totally different. ماشي? So we need to talk about, so we have to have the automated we need to talk about IKE.
So what do you mean by permanent? Because the number of hosts is always varying. If you add a new host,
لا, بس number of hosts it can vary. بس أنا the tunnel is created between the routers. The routers are fixed and permanent.
Yeah, but there can be tunnels between the router and the host itself.
No. In that case, it's between two routers. This is the type. So IKE has two very basic components. It has what we call this is the OAKLEY key determination protocol. In fact, it's called a protocol, but this refers to a mechanism. It's not actually a protocol. So this refers to the mechanism, okay, for key exchange, the mechanism. So a key exchange based on Diffie-Hellman. فاكرين Diffie-Hellman. So Diffie-Hellman uses public, key uses two public keys, either by using certificate or something like this. ماشي? But Diffie-Hellman is used to create a symmetric key from public keys, right? Using the concept of discrete logarithm. فاكرين? Using the concept of discrete logarithm. ماشي? But there was a big drawback in Diffie-Hellman, which was bravo عليك. Yes, man in the middle attack. So Diffie-Hellman also always suffers from the man in the middle attack. So we need, in addition to Diffie-Hellman, to have some way of authentication. So we need to have authentication. ماشي? طيب. In fact, this mechanism not only does it worry about authentication as part of the key exchange process, but there are some other issues back. One of them is, again, the denial of service attack. So if the IKE does not address denial of service attack, you can get a request from many hosts, okay, to establish security association, and I can send you a request from different hosts, from different IPs, ماشي? And I ask the IKE to establish security association, okay? So this way, the IKE itself as a service might have denial of service attack, right? So we also need to address denial of service attack. So this mechanism addresses key exchange through Diffie-Hellman. It addresses denial of service attack through another mechanism, which we will talk about, and the anti-replay or the replay attack also. Okay, you said, what did you say?
Authentication.
Of course, authentication طبعا. So it addresses طبعا authentication, and it addresses denial of service attack, and it addresses also replay attack. So this mechanism has to worry about all these things in order to facilitate the key exchange using a Diffie-Hellman. ماشي? Assuming خلاص this mechanism takes care of this, and we'll see how. ماشي? Now we have to have Internet Security Association and Key Management Protocol. هما الاثنين بصراحة misleadingly they call them protocol. بينما this one protocol refers to message formats and headers and فاهم قصدي ازاي؟ ايه؟ لا هو when we talk about protocol كلمة protocol تعني ايه؟ message format ماشي؟ Using بقى header how the messages are exchanged between two entities and so on, right? The mechanism talks about the these fields inside the technical. These fields, what do they mean? How are we going to use these fields? ماشي؟ زي مثلا احنا بنتكلم على مثلا in TCP بنتكلم على ايه؟ flow control. Flow control is a mechanism, right? How can we facilitate flow control? Through the window field inside the TCP header. ماشي? So the window field inside that's a protocol message or message format. Okay? And this is used to facilitate the technique or the mechanism of flow control inside TCP. ماشي كده؟ So in terms of a technique or a mechanism, here, as we said, we need to worry about all these things. We need to use Diffie-Hellman for key exchange. However, we need to address authentication as part of the key exchange process, because otherwise Diffie-Hellman will not give us this. And we need to also address denial of service, and we need to also address the replay attack. All of these have to be addressed. And we will see in the protocol that we need to have specific fields to address each and every one of these issues. ماشي كده؟ طيب, so the Internet Security Association and Key Management Protocol provides a framework for Internet key management and provides the specific messages, the message format, including formats for negotiating these security attributes. ماشي? And it consists of message types that enable the use of variety of key exchange algorithms. اللي هي الالجوريثمز اللي هي تبع الميكانيزم يعني, as part of the mechanism itself. So the OAKLEY refers to the mechanism, and the ISAKMP refers to the message formats. ماشي كده? So together they define the IKE a key management and exchange service inside IPsec. طيب, so for the OAKLEY mechanism, the algorithm is characterized by 5 important features. One is to employ a mechanism known as cookies, and cookies here is to address the denial of service attack. Okay, so cookies is to address the thwart clogging attack, اللي هي اللي بنسميها denial of service attack. Okay, so how do we do this? We don't have to really know the details much, but يعني basically how denial of service is based on the fact that you need to recognize that يعني if one host with one IP address is sending you millions of requests, what does this indicate to you? It's a denial of service, clear. خلاص يعني I'm getting 1 million messages from the same IP address. That's easy. It's very easy. It's a no-brainer, right? So that's easy to detect. Okay, so in that case, you will ignore all these requests if it's coming from the same IP. The problem if it's coming from different IPs, and that's what typically happens. Attackers, what they do is that either they spoof different IP address to give you an indication that it's coming from different hosts, which indicates that this is a legitimate request. Okay. Or they actually gain some control on actual hosts on the internet. Okay, so they see that you have a port open on your machine, so they get inside this port and they gain control from your machine. And from your machine they send requests. And from another machine they send requests. So they have like crawlers that try to see which open port you have on the machine, and they get inside, and then they get control from your machine to try to use it to send some requests to show as if it's a legitimate request coming from different hosts. ماشي كده؟ So the cookies هنا is used to really have a hashed value based on different parameters on both hosts, اللي هو the input host and the output host, or يعني the participating host. And these cookies calculated and they can be transferred, both sides. So these cookies are a combination or a hashed value based on certain parameters, the IP address of the source and the IP address of the destination, and maybe some other parameters like the port address and so on. And they try to get all these values and they hash it and they calculate what we call cookies. And then based on that, it's like a signature based on the two parties that are trying to communicate now, okay? And then they use this to recognize whether it's coming from the same host or from a different host. And based on that, they either allow or they ignore these requests. يعني without going through much details يعني, but these cookies are used for mitigating a denial of service attack. ماشي كده؟ طيب, number 2, it enables the two parties to negotiate a group. That's يعني a group. A Diffie-Hellman group. What is a Diffie-Hellman group? A Diffie-Hellman group is, as we said, if you remember, Diffie-Hellman is based on two parameters, alpha and q, okay? And alpha should be a primitive root of q and so on. So based on these values, the key is actually a function of these two values, right? So if these two values, they have certain size, the key will end up having a size which is proportional to the size of alpha and q, right? Right? So by controlling alpha and q, you can control the key size at the end. Type, what is the q size? What is the effect of the q size? A longer q size means a
Longer key.
Eh?
A longer key.
A longer key. A longer key means what? More security, better security, صح? صح? If you guess a small size in terms of crypto analysis, it's simple. But if you try to guess a very, very long key, so the Diffie-Hellman group refers to what is the size of the ultimate key that gets generated by the Diffie-Hellman mechanism. Okay, so for example, Diffie-Hellman group 1 will have a size of, will have مثلا a key size of let's say مثلا 512 bits. Diffie-Hellman group 2 will have a size of 1024 bits. Which one is more secure? Diffie-Hellman group 2, of course, will be more secure, right? So they also have to negotiate the Diffie-Hellman group. So one host would say, okay, I want to use the 1024. But the other one would say, no, I'm not capable of using that. So it's like a security level, if you will. Okay, it's like a security level. So we have to negotiate some security level. So that's also negotiated as part of the key exchange. ماشي كده? So this is the Diffie-Hellman group. And we use nonces again as a way to mitigate replay attack. قلنا replay attack can be mitigated using a sequence number, timestamp, or nonces, or something like that. ماشي? Group is like security level. Yes, Diffie-Hellman group is a security level, basically. So Diffie-Hellman group 2 is basically more secure than group 1. Okay? So if you want to use a higher security level, okay, but I tell you I cannot use this. Why? Because I'm a small device. I cannot really, because higher security level means more complexity, right? So a Raspberry Pi cannot use very high security level, okay? So we have to negotiate this as part of the key exchange. So number 4, it enables the exchange of the Diffie-Hellman public key. This is the basic, يعني. طبعا that's the basic operation. And it needs to authenticate the Diffie-Hellman group. Authentication it could be done using MAC, using certificates. We talked about different ways of doing this. ماشي? So these are the basic factors that the mechanism worries about or tries. So that's the sequence of messages. طبعا يعني looking at the details, it might sound complex, but in fact, let's just break it down in a high level. It's very easy. يعني. It becomes very, very easy. But let's talk about it.